Hey everyone, this is my submission for Teach the Doc 2, or Chapter 2. This is actually my second go with this submission because I had technical difficulties the first time, so let's see if it goes better. So the first table, we were completing the table for what the particle was, the mass, and then the relative charge. So that first part filled out the proton there, and that's its mass, and a proton is positive, so that's a +1 charge. Neutron, close in mass, just actually a little bit heavier than the proton, but relatively close. And then a neutron is neutral, so the charge is 0. And then an electron is the smallest in mass of those three, so pretty small number there. And it is negative, so it has a -1 charge. Going off to this next part, so the atomic numbers for each of the following elements. So the atomic number is also just the number of protons there. So C is 6, that's carbon, iron is 26, and then bromine is 35. And then the mass number is equal to the number of protons plus neutrons, which ended up being helpful in this next table. Sorry, kind of zooming out here. I don't have the steadiest hands. So the mass number is the left superscript, and then the 17 is the atomic number underneath it. So the atomic number is equal to the amount of protons, and in this case, this has a neutral charge. So it's 17 protons, 17 electrons, the charge is 0. I already talked about how I got the atomic number 17, the mass number 35. And using that protons plus neutrons equals mass number, that means our neutrons are 18. Moving down, we are given our atomic number again in the symbol, so 30, the mass number is 64. It has a 2+ charge. It's going to be a little bit different, which means that we're going to have 2 more protons than electrons, but our protons are still going to equal the atomic number, which is 30. So we have to have 28 electrons. And then our neutrons need to make up the difference with our mass number there, so it's 34, and it has a 2+ charge. And then the next one, we were given the mass number 65, and then the neutrons were 34, so 65 minus 34 is 31, giving us our atomic number and our symbol there. And then it does have a 3+ charge, which I got by having that it was 31 on the periodic table, so that's our element. Or then with the 3+ charge, there's only 28 neutrons, and that helped to 28 electrons. And so moving over, we got our 3+ charge there, so that's where the 28 electrons came from in comparison to the 31. And then next we were given the mass number, and then the electrons, neutrons, and protons. So I got my element there. And then just based on the fact that it has 2 more electrons than protons, it was going to have a 2- charge. Found my element by using the atomic number of the protons, and it has a 2- charge. This next one I might have to flip to the next page in the meantime. But it was the atomic mass for lithium. So we were giving the isotopes and the abundance of those, as well as the mass. So the average mass is the sum of the fractional abundance times the isotopic mass. So we took, I just made the percentages into decimals, so 0.0759 times the mass, which is 6.0151, and then again the percentage decimal is 0.9241 times the mass of 7.0160. So doing that math together got us to an atomic mass of 6.94. Let's put this over here to make it easier. This is the naming section here. So ionic compounds, we take the name of the cation plus the name of the anion and end it in "ide." So the cation here is sodium, the anion is chlorine, so it's chloride, and then magnesium nitride, the same thing. And that's Mg3N2, and the sodium chloride is NaCl. With binary molecular compounds, we take the prefix and then the name of the first element plus the prefix, and the name of the second element, and ended in "ide." So I did sulfur, iron, or sorry, I'm so sorry, sulfur hexafluoride. So we got sulfur hexafluoride. So the hexa came from the 6 with that there. And then the dinitrogen tetroxide. So it's 2 with the di and then 4 with the tetra. And then binary acids here. So you take hydro plus the name of the nonmetal and end it in ic. And then add acid. So HCl is hydrochloric acid, and then H2S is hydrosulfuric acid. Then moving down, we're naming oxyacids here. So if the anion's name ends in 8, then the acid name is determined by the name of the oxy anion ending in ic plus acid. So here it's HC2H3O2, which is acetic acid, which I just thought was a fun one to pull because working in the hospital, we use acetic acid to debride our like necrotizing fasciitis wounds. And I actually had a patient the other day that needed that at their bedside at all times to help with that. And then the HNO3 is the nitric acid there. And then so on the flip side, the anion's name ends in ite, then the name of the oxy anion ends in us, and you add acid. So HNO2 is nitrous acid, and then H2SO3 is sulfurous acid. Thank you.